So we are a company based in Zurich, Switzerland, and we, like most people here, one of the key drivers for us is energy efficiency, but we tackle the problem from a different side. We don't focus on so much on the control or data analytics side, but we focus on the side where does the data come from. So we build sensors or systems with sensors. One problem also mentioned in the very beginning when I just entered the room was that low cost, the moment you want to scale something, is of importance, and especially the total cost of ownership. And there's two keys to total cost of ownership. One is you need the price of the hardware has to be low. We usually focus there not on cheap, low quality. We think, thank you. We think that the key ingredient is using technology to improve scaling. Here's an example of one of our most successful products is a temperature humidity sensor. It's a key to optimize energy efficiency in HVAC systems, for example, but in many other cases, as the humidity is an important ingredient. And without, let's say 20 years ago, without us, there would have been only very expensive, very failure-prone devices. Using technology like a semiconductor from the semiconductor industry, you can get that device small, reliable, and even the quality up. Other examples where this can be employed, I focus here on the top right. So one thing is gas metering. We're all talking about automated metering systems, AMI. Somewhere you have to get the data and you have to be able to use the data. If the data is wrong, garbage in, garbage out, you cannot do anything with it. And here you see that's where we now start. That means it's rolling out. Most of the world still uses manual mechanical meters in the gas field. To do any analytics, you need digital instruments and the ones which last for years in the field. That's something where we are focusing on is natural gas metering. We have other things which I mentioned. I don't go in detail. Another topic I'm here that's less on that side is more the air pollution control, basically an input for power the grid in case of if there's coal power. Also here again, if you have wrong data, you get to come to the wrong conclusions, meaning that you might shut down power plants when it's not even needed just because of faulty sensor. Here again, the usual topic is we have some hardware, then we discuss a lot about the connectivity, then it goes to the cloud, we do fancy things with it. But if the hardware fails and we don't really focus on the reliability, this doesn't work. And there's, again, two ways. We can do a lot of labor, then it doesn't scale, or we do it with technology. And that's something that's the key message. I think we have to use all the technological advantages that's at our fingertips to improve cost and also maintenance cost, so that we don't get too much wrong data in our systems. I think to keep time for questions, so I skip here's an example, but we can show that if you want. You see, before 20 years ago, you needed really an equipment in the thousands of dollars to measure humidity, and now just a small sensor here does the same and has even better quality. And it lasts now for years and doesn't have to be maintained every few months. So that's an example how you can do with technology, open up new systems. Yeah, with that. Thank you. So, thank you.